My wife said you should just give me the afternoon off. I said I'm already here. So she's in your corner. Okay. So this is a very interesting note, and I don't know how many of you are having trouble with this access on, from if you got those codes for A and P from your lecture. A number of students are having trouble with that, and we may have finally solved the problem. So I finally got in touch with the people in the bookstore and had them get in touch with the people in at Pearson who have the anatomy and physiology textbook. You're having issues accessing. Our account manager looked into it. The bookstore had adopted the wrong edition for whatever reason. Okay, and they issued the codes. The codes are not matching. We have already notified the bookstore they will need to change the edition that is adopted. Our new codes will be issued to your students very soon. However, this takes some time. So students use the 14-day free access trial once the codes are issued. So if you have access to that, I don't know where you find it. You can contact the bookstore and find out about it. If I find out, I will send you a group email where those are located. I'll send this person an email as soon as I'm done, and we'll go from there. Because we've had quite a few of these, and I mean I'm running into a resistance at Pearson because why do we have to keep doing this? Your bookstore should cover it. And the bookstore, it's like they finally got back to me. It's like I had to write first was the nice little email, and the next one was a little more, I do need to hear from you today that you are aware of this problem and you're working on it. And magically I got a response. So I was already starting to get it's you guys shouldn't be bothered by this. This should be a slam dunk. In any university you go to, any college, any university, that you should be able to confidently buy things whether the bookstore is on site or online. That whatever you're going to buy is going to match what your needs are. And if it's an access code, you should have the access code. That's why you're paying all this money. Don't get me started. My wife already yelled at some. She left her cell phone at Goodwill up by us in Cranberry. She drove about a half an hour away to Sam's Club. Goes, I left my phone. Came back for an hour. She had her iPad so she could ping it. Nobody would help her. Finally, with the aid of another customer, they finally got somebody to help her. An hour of pinging. Today she went back there. She checked out with some stuff, and she let them. How did you find everything? Well, at least I found some help today. My wife will never know that you're never uncertain if she's unhappy with you. She speaks, and you know what happens when she tells me that? You have to do this. You didn't do that. I look her right in the eye. I know just how to talk to her. Yes, dear. I know. I'm good like that. Yes, dear, you're absolutely right. Doesn't matter. So moving on. Let's see what he says about the microwave. That will work. Thanks. We're here. Quick. Ooh, I don't have a mask. You know I can go right into the club. Yeah. Dr. Robbins was the one who discovered it. So you guys have Dr. Okay. So much for that. That's our correspondence 101. I loaded a couple of things for you. So on your Blackboard, because I saw that I had things because I usually teach the A and P once the first year in last 6 or 7. That I'm not doing the 12-10 lecture, the lecture component of this, for at least 2 of the sections. I usually sometimes I'll have all 3. But everything kind of changed around this year, and that's fine. So in addition, here's your week 1, the stuff that I had showed you before, the YouTube, which was for my advanced students, because ours didn't record. I have, when you started the biochemistry unit? Yes? Atoms, electrons, what's your sign, positive, negative, that type of stuff. Okay, here it is. So, I just downloaded it again. That wasn't too smart. So, yeah, fine. So, I mean, I did this from a different textbook, but with valences, polar and nonpolar valence, ionic. We don't do it here. That's a lecture component. But if this helps you, use it. And share it. If somebody has it and their lab instructor doesn't have something, please feel free to share it. you always do better when everybody helps each other. Soon enough in your life, you run into cutthroat individuals. It's no fun. Okay. Short anecdote. When I started in medical school, I was a chemistry major. A lot of the people I started with did not. It's very different than it was years ago. A guy had a master's in French. Somebody was in business. You know, they got in because they were trying to avoid the draft and the Vietnam era. It's a very long story. I had biochemistry at least twice before, at different schools and things like that. I had them come over to my apartment where I lived, and I taught it to them. I could have said, "Oh no," and I could have gotten a great grade, and they could have suffered. A lot of people are like that. It's not only do they have to succeed, you have to fail. So if you anything I give you, please share it. If you're so inclined, not mandatory, no way I can check. So it's about the different molecules, carbon to carbon bonds, blah 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 blah, isomers, protein structures, everything. So if it helps you, great. Next event coming up from there that I had. I just like it's on the downloads where I put it. The other ones we'll look very briefly. You're going to do the cell. We've all done the cell too many times. This is this is actually taken from a micro textbook, but it talks a little bit about cells that you might find with the different organelles and things like that. In lab, first of all, lab is less microscopic to me and more macroscopic. So it's stuff that we can see and touch, like the bones. We're going to do microscopic stuff. But review aspects of the cell. Review that kind of material. So you'll know what a nucleus is, and the whole idea of these systems, the endomembrane system, the series of membrane, and the whole ball game for our cells, which are called, and I frame this as eukaryotic cells. Eukaryotic cells are the cells you've been studying forever. Okay, they have nucleus, they have an endoplasmic reticulum, and mitochondria. Those are membrane-bound organelles. Just everything is compartmentalized. It's very, very sophisticated. When you deal with micro, most of it's about bacteria and then viruses. The idea is it's about what's called a prokaryotic cell. That means kind of before the nucleus demonstrated itself. It has DNA and RNA like every other living thing, but it's a poor analogy because there is an internal structure. It's like somebody took a bunch of stuff and put it in here, but no membrane bound organ. It's just a container. And it really is much more sophisticated than that, but nothing like our cells, which is the unique feature that you have to become familiar with. So it's a little bit of that stuff that you'll find in there. And I think there's one more thing I had in that. Okay, I had the eukaryotic, I had that outline, and I loaded that PowerPoint, which hopefully they give you. And if there's a PowerPoint you want to see that you're not getting, I don't feel it's proprietary because I've had them posted forever. And that type of thing going on. So that's kind of what we would be looking at just as a start, and I have other ones that we'll look at. But this is, after you do the biochemical chapter and lecture, you do this before we get to the lab stuff today. And it just tells you about cells. I'll just go, and to me, this is lecture stuff. Okay, smallest structural and functional unit of life. Basically, what happens in a cell, you can sort of take that individual cell that make up a whatever functioning unit, and you understand it. We figured the old saying was, if you understood the cell in the system, then you understood the system. Now it's much more, and you'll learn about this, it's much more molecular biology. So you're going to learn about the molecular interactions. It's not just the muscle cells are compressing upon one another or sliding over. You're going to learn how they slide and why they slide, how the nerve signals are transmitted, the electrical current that's involved. What's something within this that follows this chapter, which is extraordinarily important, called resting membrane potential. Because all of our cells have charge on the outside and charge on the inside, and it creates a very interesting barrier that periodically is breached. So all of that is coming your way. So cell theory is just that. It's very simple. We're made out of cells, and all cells come from pre-existing cells, obviously except the first one. And that came, as a process of evolution. I'm not an evolutionary expert by any stage at all. So that, and everything is on a cellular basis, the whole structure and function. You're going to see a lot of types of cells. They're based on shape, size, what's inside of them. And what's inside of them tells you how they work. When you see a cell that's rich in something called rough endoplasmic reticulum, that means it produces a lot of proteins, typically for export. Think of your pancreas making insulin. And people who don't have a pancreas that makes sufficient insulin have diabetes. They have a lot of, liver cells have a lot of what's called smooth endoplasmic reticulum. That's a rich, fatty kind of material. So what does they have a lot to do with? Processing fats. And so, and detoxification, because most things that are dangerous to us are fat compatible, interestingly. So, I mean, when you see the cell, you get an idea of what's going on with it. And they show you this interesting parts. Today, we're going to talk a little bit about lining cells and connective tissue cells. And so lining cells, cells are packed closely together. Connective tissue, they're connected, but they're not next to each other. The cells aren't connected, but they have fibers that interconnect them. Some cells are a misnomer. That's a red cell. Yes, ma'am. Oh, I shall. No, you're fine with that. No, I won't disturb Dr. Hannah. That's her animal behavior lab. She wants me to read my book. So you can see some of the cells are up there. So red cells are a misnomer, meaning they're really not a cell. Why? They lost their nucleus. It's part of its maturation. It doesn't need a nucleus because it's done making what are called hemoglobin inside, and basically it serves as a conveyance for oxygen. Pure and simple. That's what it does. Muscle cells are very sophisticated cells. There's a lot of internal structure, very hard to replicate. Fat cells are just that. They're storage cells. They have fat, so much so that it pushes everything aside, including the nucleus. Macrophages are a specific white blood cell, and they have those tentacle-like projections. They're constantly either sampling the environment for properties of bad, so to keep your immune system, or it does something else in the sense that it's just there and it's activated if there's been injury. So you cut yourself. Okay? Immediately, part of that inflammatory reaction are chemicals that are released that basically summon macrophages to the wound site because you're going to be damaged, it's going to be gobbled up. And basically, those chemicals will do something. It's a fancy word called cytokinesis, making cells move. And the name of the chemicals they release whenever you cut yourself, injure yourself, twist an ankle, whatever it is, are called cytokines. And basically, they're summoning the cells from the bloodstream. Hey, I need help. Sort of like Price is Right. Come on down. The part that drives me crazy when you have people there and you're the last person, you should always do. It's like the high bid is 370, and it's usually under it. You should take 371, you go 360. I was watching that show before the late Bob Marker took over, just in the 50s. Okay? Nerve cell has those very long projections. They can be up to a meter long, 3 feet. That long thing in the middle called an axon. And then a sperm cell, which is really kind of a half a cell. And really the cell, the component, all it really has that's of any cellular relevance is up here. Everything else here is just getting it to the point where it's going to fertilize an egg. This is the genetic material. So really it's just a structure that conveys genetic material to its target efficiently, as you will see. So you can tell a lot about, I mean, obviously you look at a sperm cell and say, that's got to be moving around. Gives you an idea. So I do this little thing for the cells just to get you oriented to them without going crazy. Minimum equality. By definition, not only is the cell has its own membrane, there's no such thing as a cell wall in animal cells like ours. We get structural rigidity from the components inside and the way they're arranged. Rather than a plant, which gets it externally from its cell wall, which is made of cellulose. And obviously they're very, very strong if you want to think of, a plant material like wood or something like that. So we have to have an outer boundary, and by definition, any plasma membrane, and you'll get to this in your lecture, it's all about movement across membranes. Diffusion, facilitated diffusion, osmosis, active transport. Extraordinarily important. It's really how things get done. Really, really important. The material that's inside, called cytoplasm, what makes it a plasm between the liquid and the organelles is sort of a gel. We call it a sol gel. So some things are dissolved, some are not. So it's not like Jello type thick, okay? But there's almost like a gelatinous component to it, and they have a nucleus, and everything else is just add-ons. And some cells have more of them than others. They all have certain things in the middle. And so rather than, I always would draw that, what we got when we were in school, the box, the rectangle with a circle in it. There's a cell. Nothing could be further than the truth. There's a lot going on inside the cell. So you have all of these structures. You have the nucleus. So you follow the cursor, and inside of this giant thing with a double membrane. Are you hearing okay? Am I making it loud enough? Ladies back there? Okay. And you have all of this, and look at those little openings. They're called nuclear pores. That's how stuff gets in and how stuff gets out. The only stuff that doesn't get out is the DNA. It's too big to get out. Okay? That's what's unique about DNA. It's a giant molecule. Only the components to make it, or what it makes in the form of RNA, which is big too, but sufficiently small to get through those openings. All of those, they're all part of the process. It has its own plasm. That's called a nucleolus or nucleolus, depending on who you listen to. And that makes something called ribosomal RNA. It's a lecture thing. You probably had some of this in different kinds of RNA messenger, transfer, ribosomal, ringing, Is this familiar language to you? See, you're already, yes, ma'am. If you didn't have it, that's okay too. Okay. And you can always stop me. I realize it's a little bit different arrangement that's there. This is endoplasmic reticulum, rough because it's got ribosomes studded on it. So on paper, it looked rough. But the reality is it's not. I mean, these are just items that periodically embed themselves where certain kinds of protein. It depends on whether the proteins are made here or out in the cytoplasm. They're called free ribosomes. These are bound. And you'll find out about the difference between them. And ribosomes, because while DNA is the instruction manual, ribosomes is where the protein's assembly. And believe me, everybody, you are what your proteins say you are. That's what genetics is all about. I mean, we can modify them. I mean, if you have athletic skills, you perhaps can improve your athleticism. If you don't, you can't. Okay? I mean, so if genetically you don't have it, I told my earlier class today, I have a vertical leap of about a half an inch. I was never going to be a basketball player. I can't even get off the ground. And interestingly, it has to do, to some extent, with the genetic arrangement of different kinds of fibers in muscle that allow someone to be Michael Jordan and someone else to be me. Okay. He's a basketball player of some renown. Don't we like sports here? It's football season. I feel better. If the Steelers don't win, I won't be happy. I'm worried already because they did so great preseason. Here's a clue about preseason. It doesn't count. Mitochondria, power plant. Interesting, it's got a double layer of membrane. You'll learn about that quite a bit in micro because it's called endosymbiotic theory. This probably came from a more primitive organism like a bacteria that was incorporated and not destroyed because it was useful. And so there's evidence. Why is there evidence of that? Because the only area that has its own DNA and different ribosomes. It's got a strand of circular DNA. Our DNA is paired, that 23andMe stuff. And this is circular DNA, which is bacterial, and it has ribosomes that are slightly different than the ribosomes, let's say, that are over here, based on their density and their subcomponents. And you'll learn about that probably more so in micro than in A&P, depending on how much they want to share with you. So that, just be familiar a little bit what these do. Lysosomes have enzymes in them, potent proteins for digestion and defense, et cetera, et cetera. And so that's a little bit of what you can look through this. Terms that you probably should remember more for lecture than here. We use certain abbreviations a lot, or acronyms a lot. Intra and extracellular fluid, those are frequently used. So it's like, my day and age, we call it fair game, meaning you could put that on an exam and expect the students to know that. So normally it's best to spell them out. If, for instance, if you put that on a medical chart, everybody would know what it means. And for those of you going into nursing or similar fields, charting, there's certain things you can do and certain things you can't. Certain abbreviations are acceptable, certain are not. And it's important because the only thing between you and a lawsuit is that chart. Take it out on the business end, the wrong end of lawsuits for malpractice. It ain't fun. So the other thing, you'll do this, the fluid mosaic model, and all the components, all the different things that are in there you're going to do, etc. So that's as much as I wanted to share with you about that, because I know you're going to cover it in lecture. Usually on my first exam, it's sort of, maybe I get half of that chapter. I do the introductory chapter in lecture and the biochemical chapter, and then some of this chapter and move on. Okay. Oh, good. So that's I wanted to take 20 minutes or so of introductory to acquaint you with what cells are and what they do that are there. Our purpose in lab, and normally what I know what Dr. Robbins does in lab, he brings in the slides, and this is a micro lab, we could look at slides all day. And depending on if they ever get this fixed, we may actually do that. But I think projecting the slides is just as valuable. I am not. A lot of places, and it's not my preference, if anything, I'm against it, is they will, you may have heard of people doing this, when you're learning about tissues and cells, they'll have a practical, meaning they'll set up microscopes for the slides, and you go like station to station, have to identify. I can't imagine having an entry-level student, this level, doing that. We didn't do this sort of. It's one thing if it's something obvious like a bone, and you'll see some of these bones very obvious, blood, fatty tissues obvious. Some of the others are not so. And that, maybe so your friends in college or in the other many lab sections may actually be doing this. It's fine. Everybody teaches differently as long as we cover it. You're just pushing stuff. Okay. Moving on. So I will now get back and show you what I really wanted to cover today, particularly, and that's lining tissues. I will give you fair warning. This is chapter 4. It's on week 1 of your Blackboard. I have an outline, a tissue outline, already on Blackboard for you to. So all of this stuff is already in print. So it's divided into 2 basic sections: lining tissues and connective tissues, and some others at the end of the connective tissues. Not a big deal. This is the connective tissue part. Make me look good. You're not advancing. Don't be a problem. Help! I'm in trouble. Oh, sugar. Don't tell me. It froze. Close your eyes. Ay, ay, I gotta go through this again. There are days when you have real problems with this. I wonder if is there any way to escape from this without having to? This is ludicrous. Okay, I have the students come to a lab for the specific purpose of getting all this right. It's going to take me about